Okay, so on this sheet, let's take a look at number 5. Number 5 says 4 firefighters are holding a square net, one at each corner. Okay, so this is my square net drawn 3D. I hope you appreciate the amazing artist that I am. Okay, so when they're holding this square net, they're clearly not holding it taut, because if they held it taut, the person who steps out of the burning building from some balcony comes down. If it's taut, if it's perfectly flat and tight, it's going to be like a trampoline and they're going to bounce back up. So they're holding it so there's a little dip in the center, and that allows then there to be some give. Okay, and so that's what the question's talking about. It says each person exerts a force of 200 newtons whose line of action passes through a point just below the center of the net, right? Because this point is not even with them. And so, like, one dude is pulling upward this way, one dude pulling upward this way, another one this way. So if we were to look at any one force, it would be at an angle, right? So this would be the F. And the question says it's 200 newtons. And it would have an X component going out towards them and a Y component upward. So each of them would have that. So these two guys on either corner, their X component is going to cancel each other out, right? They're just going to be pulling opposite each other. And these two guys, they're going to be pulling opposite each other, so their X components would cancel out. But all of them have a Y component, right? So there would be the X and this would be the Y. Sorry, X and Y. And this one would have an X and this would be the Y. And this one would have an X and this would be the Y. And this one an X and a Y. So the X components are just going to cancel, the ones across from each other. And the Y components then will add up. And it says in the question that the net makes an angle with the vertical of 60 degrees. So the vertical is here. So it's saying this angle in here is 60 degrees, which means this one must be 30. So we can find the Y component of each firefighter's force. It's the opposite side, so it's going to be sine. So sine of 30 is going to equal Fy over 200 newtons. So Fy will equal 200 newtons sine of 30. Sine of 30 is a half, so Fy will equal 100 newtons, and it will be up. So each firefighter is pulling with a force such that its upward component is 100 newtons, and there's 4 of them. So the net force on the blanket or the net will be 400 newton, 4 times 100 newtons. So the net force will be 400 newtons up. Okay, because like I said earlier, the X components are just going to cancel each other out. Okay, so that's it for question number 5. Some of you already saw question number 2, so you can stop the video if you did. Number 2 says 3 ropes pull down on a weight scale that is suspended from the ceiling. One rope pulls straight down with a force of 200 newtons. The force of each of the other 2 is 200 newtons as well. They act on either side of the central one at an angle of 30 degrees. What is the reading on the scale? Okay, so the scale is like a scale that we used in the lab, okay, or like the one hanging from my ceiling. And so it's going to read the force that's being pulled down on it. So there's one force, we'll call it F1, that is straight down, 200 newtons. There's one force that's being pulled out at an angle, F2. It is also 200 newtons. So it has a component going straight down and a component going out to the side. This will be F2x. This will be F2y. This angle, they tell us, is 30 degrees. There is a third force coming out this way. It is also, it's F3, it is also 200 newtons. So there is an F3y and an F3x. And this angle is also 30 degrees. Okay, so not quite drawn to scale, But the hypotenuse of both of these two are 200 newtons. The angle's both 30. So hopefully you can see that F2x, which is pulling to the left, and F3x, which is pulling to the right, are going to be equal but opposite and are just going to cancel each other out. We could find it. It's the opposite side of that right angle triangle. So you would do sine of 30 is equal to Fx over 200 newtons. So Fx is equal to 200 newtons sine of 30. So Fx is equal to 100 newtons. I didn't put in 2 or 3 because they're both the same, but F3x would be 100 newtons to the right, and F2x would be 100 newtons to the left, and so they would just cancel. So then what we need to do is find the y components, because it'll be the y components that the scale will read. So F2y is the adjacent side, so it should be cosine. So cos of 30 will equal F2y over 200 newtons. So F2y will equal 200 newtons cos of 30. Cos of 30 is 0.866, so 86.6 times 2, 173.205 newtons acting down. Number 3 will also be cos of 30 for the y. So cos of 30 is equal to F3y over 200 newtons. F3y will equal 200 newtons cos of 30. So F3y will also be equal to 173.205 newtons, also acting down. So we have 3 forces now acting down, and we're looking for the F net. The question says, what is the reading on the scale? And the scale is going to pull back with the same force that these 3 forces are pulling down. So it'll be F1 plus F2y plus F3y. They're all acting downward, so they're all, you're going to add them all up. So it'll be 200 newtons plus 173.205 newtons plus 173.205 newtons. So the net force will be 345.43.41 newtons. Okay, it's acting down, so the scale would have to pull up with a force equal that. And so the scale should read 345.43.41 newtons. Okay, so that number 3 and number 4 are on separate videos, so that should be the end of the back side of the sheet.